Hello, here's a dynamic programming problem from Edexcel. It was the international paper 2014. There were only a couple of international papers for D2, and this is one of them. Before we start the problem, one of the things I always say about dynamic programming that's important to consider is the fact that we're working backwards. Now, what does backwards mean here? Well, it's hard to say. We could equally go in any direction and say it's backwards with this particular problem, and the examiner is well aware of this, and that's why they've told us to consider bicycle first and to do it in that order. So bicycle is last, if you like, the last one to work with, or doll's house or train set. We really shouldn't worry about that too much. Here's a similar problem for those of you working in the textbook, example 7 from page 221 about fruits, where really backwards or forward, we could do it in any direction. We couldn't say that it's wrong because backwards, forwards in themselves are not particularly meaningful. Right, okay, so let's consider before we do the problem, talk about state, action and destination. The state here will be the number that are available for that task. Okay, so that could be 4, 3, 2, 1 or 0 in this particular problem, because there's 4 workers and 4 could definitely do bicycle, or none of them could, or anything in between. Action is the number that are actually do that task. Okay, and the destination is the number available for the next task, for the following task. And because bicycle is being considered last or first, depending on, but last, there won't be any available for the following task. So that's 0 in the destination column, and action is just the same as the state column in this example. Okay, so we're actually pulling the numbers from here for this table because we've not got anything else to consider at this stage. So we've got 350. If all of them do bicycle, and none of them, as we follow it through, we'll find that none of them do the others. That's 350. If 3 of them do bicycle, it's 260. They should be starred because each one of these in themselves is a state in itself. They're optimal. Okay, there's only one of them, but strictly speaking, it's the optimal one, and they should be starred. Okay, so that's the whole stage considered. Now we can move on to doll's house. Now, of course, we've got obviously another stage to consider before this, but there's undoubtedly all 4 of them could be assigned to doll's. There could be 4 available for state doll's house, no matter what happens from the state before, which is train set. And then also it's possible that they all actually do doll's house, 3, 2, 1 and 0. If they all do doll's house, then of course there won't be any available for bicycle. But then if the 3 of them do, and do doll's house, but 4 were available for doll's house, and there will be 1, 2, 3 and 4. Okay, so the whole essence of dynamic programming, as I keep saying, emphasizing, is that we are pulling down starred values from before. So here we are pulling down the 0 from before, which is just 0. Okay, so that's just 0 there. But if that is the case, we've got 4 doing doll's house, so that's 3, 3, 5. Okay, now for this one here, we are pulling down the 1 value from before, the state of 1, which is destination here from before, and that's 80. Okay, so it's 80, and we are adding the 3 from that one, and that equals to 325. Okay, for this one, we are pulling down the state of 2 from before. So that's 170. Okay, so that's 170 we're pulling down, and that is the 165 that we have there. From that means that 2 workers are assigned to Doll's House. That's 165, so that's 335. Okay, now for the next one, it's destination 3, so that means it's pulling down the state of 3 from before. That's a 260. But 1 is doing that. That's 95. So that's 355. Okay, and finally, this one's got a destination of 4. That means we're pulling down the state of 4 from before. So that means 350. But there's actually nothing there's no action there. No Doll's House are being made, of course. So that's 350. Now we've completed a state now of the state of 4 for the stage of Doll's Houses, and we need to star the optimum one. We're looking to maximize the number of toys made here, so we're starring the 355. Okay, so now we're on to the next state for Doll's Houses. So there may be 3 workers available. And of course the most that can actually do the Doll's House is M3, but we can have 2, 1 and 0. Okay, then obviously if 3 were available and 3 actually do Doll's Houses, there won't be any available for the next stage, and the following will proceed accordingly like that. Okay, so now let's look at the numbers again. Okay, the 0 is being pulled from before, so that's 0. That's the start value being pulled. And then 3 is the 245. So that's 245. Okay, the 1 comes from here. So that's 80. But if that's the case, the action is 2, so that's 165. 2 are making Doll's Houses. So that would be also equal to 245. Okay. And then we've got a destination of 2 here, so we're pulling down the state of 2 from the stage before. That's 170. Okay, then we're adding on whatever the action is, which is 1 person doing a Doll's House, which is 95. And that equals to 265. And then finally for this state we've got 3. Okay, so we're pulling the as a destination, so we're pulling the state 3 from before. So that's 260. Now in this case, nobody is making any Doll's Houses. You can put +0 there so that we've got 2 numbers. That's 260. Now we've completed that state. We're looking to optimize, which is maximize. So we start that value for that state. And so moving on to the next state, which is 2, we can just see that there could be 2 available, 2 doing the job, 1 and 0. And then we'd have 0, 1 and 2. The start value we'd pull down from the 0 is obviously 0 from before, but 2 doing the job would be the 165. That's 165. Okay, the start value we'd pull from before would be the 80, Okay, 80, which would be pulled from before, and then one doing that job, which is 95. So that's 175. Okay, and then the 2 value that we'd pull is the 170. But nobody would be available, nobody would be doing dolls houses here. That would be 170. We're seeking to maximize, so we've got 175. So that's that state done. We've now got the state of 1 to do. If there's only one worker available for dolls houses, then obviously that one person could work on dolls houses, in which case they would not be available for the next stage. Or no one could do it, in which case 1 would be available. Now, we're pulling down we've got a destination of 0, so we're pulling down the 0 from before here. So that means we have got 0, but that one person would do the job, so that's the 95. Okay, if the destination is 1, we're just pulling down the 80 from before. But there would be no one then doing dolls houses. So that's 80. We're seeking to maximize, so 95 is that optimum for that state. Okay, so I've also completed the state of 0 here. At this stage, that one actually applies that no one's actually available for dolls house, presumably because they've all done train sets, as we'll see in the next state. So we're doing train sets finally here. There won't be any more possibilities to consider really here. Obviously, there's always 4 available at the start because we're considering train sets first. And if we look at the actions, we could have 0 to 4 doing train sets, and then the destinations would be as follows accordingly. Okay, now pulling down, if this is if no one does train set, we've got destination of 4, we're pulling down the 355 from before here. And there's no number to add there because no one's doing train sets. Okay, if the destination is 3, we're pulling down the 265 from before. In which case 1 person is doing train sets, that's plus 100. So that's 365. Okay, and then if the destination is 2, we're pulling down the 175 from before. In which case 2 are available for train sets. So 2 are doing train sets, that's 180. So that's 355. And then the 95 plus the 260. And that equals to the 355. And then finally the 0 plus the 340 completes the table. Now the optimal one of these is the 365. So let's trace back. That means that we've got 1 person doing train set. That the destination there was 3, so that means that 1 person is also doing doll's house, and the destination is there is 2, and 2 are doing bicycle. So bicycle are doing 2, 1 person doing doll's house and 1 person doing train set, and the optimum is 365. So that's the answer to part B, and that's the question done. Okay, that's a bit of